Got questions about the Brazos, no more unknowns. Ever wonder where that water comes from or where it goes? We're unpacking the Brazos River.
Communities along the Brazos River are growing at a record pace, with new families and businesses arriving all the time. But with all this growth comes a huge question. Will there be enough water to go around? It's not just a problem for the future, it's a challenge we're facing right now, especially in places like Eastern Williamson County. This area is seeing explosive growth, and that means a much greater demand for water. How does one ensure there's enough water for everyone? Let's find out. Today we're talking about how the Brazos River Authority is working to make sure there's enough water for this region, not just for today, but for generations to come. I'm Charlie Shugart, and I'm with our Public Information Office, and this is Unpacking the Brazos River. Joining me today for the second time on our podcast is Brad Brunett, BRA Chief Operations Officer. So glad to have you back.
Thank you. Good to be here again.
And for the first time, we're joined by Program Manager Mandy Cullar. Thanks for joining us.
Thanks for having me, Charlie.
So tell us a little bit about your history with the BRA.
I started with the BRA about 15 years ago, and I actually started in a wastewater lab. So water quality has always been really integral to what I've done at the BRA. And I've been really, really fortunate to have a lot of opportunity for growth within the organization. And so ultimately, that got me to where I'm at, which is overseeing infrastructure projects.
Awesome. Great. Well, we appreciate you being here.
Thanks.
So if you're familiar with the BRA, depending on where you're located in the Brazos River Basin, your understanding of what our organization does can depend on, for example, where you live or your needs. Some of those who live on lakes Possum Kingdom, Granbury, and Limestone think of us just as owners of those water supply reservoirs. If you're a municipality in the lower portion of the basin like Hutto, Sugarland, or Richwood, you may know us because we operate your wastewater treatment plants. And if you live in the East Williamson County area, you may know us for water treatment. So that brings us back to today's topic. What is our involvement in water treatment?
So yeah, I guess I can take that one, Charlie. The East Williamson County regional water system that we operate today, we got involved with that back in 2004, I think. We originally purchased a water plant from the city of Taylor, and our thinking back then, we kind of foresaw the growth that was coming to Williamson County. Back then, it wasn't near as rapid as what we're experiencing today, but we saw the need for a regional water treatment system there to serve that eastern part of Williamson County. And so we purchased the plant from the city of Taylor to turn it into a regional system. In about 2006, 2008 timeframe, we expanded it from about 4.5 million gallons per day, which is what it was when we purchased it, up to roughly 13 million gallons per day. And we've since constructed a number of other improvements. We put in a new intake structure that makes the water supply more drought resilient, where we can access water in the lake if it gets lower. We put in backup generators to ensure that we can operate the plant with power outages and those kind of things. And once we bought the facility from the city of Taylor, they were the original customer, but since then we've added 2 others. So right now we serve 3 wholesale customers from that facility. It's the city of Taylor, the Jonah Water Special Utility District, and the Lone Star Regional Water Authority. And each of those entities supplies water not only to their direct areas, but some of them supply water to additional customers. Like the city of Taylor has a small contract with Hutto for some of that water. And the Jonah Special Water Utility District is a rural water district. They have a very large footprint, and so they supply a broad geographic area. And the Lone Star Regional Water Authority does as well. Their territory goes back up north on Interstate 35 up through the Gerald area all the way up to Bell County.
Can you give us a little bit of overview of what water treatment is like? Why are we treating water? Why can't we just take it straight from the river or lake and provide it straight to people?
There are physical contaminants in your water. There are biological contaminants, chemical contaminants potentially, and then organic matter in your water. So treatment really helps to remove or reduce a majority of those things. And then obviously the disinfection process makes it safe to drink so that you're not going to get sick from your drinking water.
Can you tell us how long a process like that takes?
I think it depends on the demands. When we're feeding water through the plant, there's specific detention times that have to be met in order to provide adequate treatment. We could be in a situation where if we're running at maximum capacity, the water's literally coming in, being treated, and going immediately out.
Right. I would say 1 to 2 days if we're operating at a high capacity from the time the water comes in till it goes out. On any given day, if we pump the water out of the lake into the terminal storage lake, it's just like a smaller lake located at the plant. So we pump the water from Lake Granger into that terminal storage, and it holds about 20 million gallons total. And if our plant is operating at peak capacity like we were, not necessarily this summer, but the summer of 2024, we were up around 13 million gallons per day. This terminal storage reservoir holds 20. We were using 13, so that's, less than 2 days worth of water in that terminal storage. And so that's where I was coming up with the 1 to 2 days that it would take for a drop of water once it got to terminal storage to go through the system and be treated and pumped to the customers.
Are you able to provide any sort of analogy of how much water that is?
On a peak day, if we're producing 13 million gallons a day of water and sending that to the customers, that's the equivalent of about 40 acre feet of water. And 1 acre foot is about a football field covered 1 foot deep in water. So picture 40 football fields 1 foot deep in water. That's about how much water we're putting out on a peak day.
Yeah, that's a lot.
It's a lot, but it's all relative. When you look at smaller communities, it's much less. If you look at a large system like, say, City of Austin, City of Dallas, that's very small.
Right. Okay.
So it's relative to the size. And I think in terms of the number of customers that take our water, this is a pretty rough estimate, but it's probably somewhere between 50 and 70,000 people are served from this system.
So we're doing an expansion project here at this plant. Before we dive into what that looks like, why? Why are we looking to expand this?
Well, it's basically providing water to meet people's everyday needs. We all here in this country enjoy the benefit, and sometimes we take it for granted that when we turn on the faucet, water comes out, clean water. And for the most part, other than maybe extreme droughts, we're not limited on our water. And it's important for the area so that can continue, so that, people continue to have a clean, reliable supply of water, knowing that when they turn that faucet on, there's going to be clean water coming out.
We're seeing really unprecedented growth, population and industrial growth in Williamson County, and particularly in East Williamson County. So that's really the driving factor here.
When we bought the plant from the city of Taylor, we expanded it quickly, as I mentioned earlier, from 2004 up until probably maybe right before COVID in 2020. Our water needs and use from the plant were increasing very gradually. It was just, relatively stable. But since about 2020, we've seen more of an exponential increase. We've gone from a peak use of maybe 7 or 8 million gallons per day prior to 2020 to 13 million gallons per day over that 5 or 6 year period. And so, we're at the point now where our plant is pretty much maxed out and we're having to do the expansion to meet those growing needs.
Did something happen in 2020 to spur a bigger jump than the gradual increase that was happening?
It was somewhere around that time that the Samsung semiconductor chip facility, or I said semiconductor, it's a chip facility. I don't know if they're exactly the same, but it was somewhere about that time that was announced. And, once that was announced, the area was already growing. Williamson County with Round Rock and Georgetown, those areas are growing, outward and expanding to the east. So we were already starting to see some of that. And then with the Samsung facility, that kind of kicked things into another gear in terms of, that major infrastructure development coming in and all the people that were going to be needed to build it, to support companies that are going to be needed to provide, materials or supplies or support to that overall facility. And so that to me is kind of the trigger of when we really saw things starting to increase, was after that announcement was made. And I want to say, I'm trying to remember, it was around 2020, I think. One thing that's important for people to know, the water for the facility at Samsung is going to be coming from groundwater through a pipeline that goes about 20 miles east of our plant. So they're not getting water for Samsung directly from the BRA because, frankly, couldn't get the plant expanded fast enough and be able to supply all the water that they need without putting our customers in jeopardy of getting water to people's homes on a day-to-day basis. And so the expansions that we're talking about aren't to supply the facility itself, it's to supply all of the people that are coming to the area, partly in result of the facility.
So let's talk about the expansion. How do you expand a plant? What does that look like?
So when we talk about the East Williamson County plant expansion, we're really looking at it as a system expansion. And so there are kind of 4 main components that we looked at expanding. So the first thing that we looked at was some type of immediate boost to our production capacity, which we got through re-rating the existing plant capacity. So when we did that, we hired an engineering firm. They came in and they really tried to pinpoint efficiencies of where we could get a more efficient, productive treatment process with very minimal cost and impact to operation, right? And so they were able to successfully do that, and that actually boosted our plant capacity from around 13 MGD up to 14.5 MGD just by tweaking our treatment process.
Okay, so it didn't really involve like construction or building new work.
That's correct. It was more of an administrative exercise. There was, some water quality studies that had to be done within the plant itself during the treatment process. But then outside of that, it's really administrative with TCEQ.
Yeah. And that's the Texas Commission on Environmental Quality.
That's right.
So what difference did that make?
So it boosted our treatment capacity about 1.5 MGD. So it gave us that kind of a little initial boost to, in the very near short term, increase our treatment capacity so we can get more water to our customers.
One of the reasons we did that was because we could do it relatively quickly, whereas some of the other stuff Mandy's going to talk about, the other 3 phases, take more time. And had we not done that re-rating this summer, and especially last summer, we would have been probably in maybe stage 2 or 3 of our drought contingency plan, where we would have been restricting water use by our customers just because the plant couldn't keep up on those hot summer days. And so I mentioned earlier that we've maxed out at about 13. I think it's slightly a little bit less than that, but our drought plan for the plant has trigger levels that once we get to, let's say, 85% of the max capacity for 3 days in a row, we go to stage 1. If we get to within 90% for 3 days in a row, we go to stage 2. And had we not added this extra 1.5, it doesn't sound like a lot, but adding that 1.5 has allowed us to pretty much not have to implement our drought contingency plan for the plant because its capacity has been adequate to take care of the people's use without doing that.
You mentioned last summer and really the summer before that the demand was so high. Why was the demand so high?
It primarily has to do with rainfall. So this summer in 2025, we've enjoyed a lot of rain through the summer, especially back in July. And typically our plants use or produce a lot more water in the summertime because in the summertime, that's when people are watering their grass, more car washing, more water use in general. And just for comparison, in the summertime, many times your peak water use will be more than double what it is, say, in January or February. And so this summer we had a lot of rainfall, and so people didn't need to water as much, and that resulted in less water coming from the plant. Last summer in 2024, it was much drier, particularly toward the end of the summer, and people were using more water mainly for probably outdoor irrigation and landscapes type stuff. It's kind of 2 separate drought plans for that area. Number 1, looking at, do we have enough water in the lake? And number 2, do we have enough treatment capacity to treat what our customers need?
And I don't think we mentioned this. Lake Granger isn't a BRA reservoir. So how does that work?
So, right, it's a Corps of Engineers reservoir, and the Brazos River Authority has contracts with the Corps to store water in 8 of their reservoirs in the Brazos River Basin. And so essentially the way that it works is the water supply component of Lake Granger and all the other Corps reservoirs that we contract for, BRA is in control of water supply. The Corps of Engineers is in control of flood control. So when we have big rains in the lake, like Lake Granger rises up above its normal level into the flood pool, the Corps is responsible for managing how they release that flood water and when. When the lake is at its normal level or below, the Brazos River Authority has the contractual right with the Corps and then the state water rights from the state to supply that water to our customers.
Okay, so we talked about the re-rating of the plant. What's the next step? What is another project for this?
So as it stands currently, water that's treated at East Williamson County comes from Lake Granger. So that's all surface water. We have a well that is in the Trinity Aquifer that's on site on our facility. And the goal is to take that groundwater, cool it, disinfect it, and blend it with the treated surface water. So that's going to add some additional capacity that we can deliver to our customers without actually having to expand the treatment plant itself. So it's almost two separate trains of water that are going to be combined into one for delivery.
So have we not been using water from the Trinity Aquifer before?
It was constructed within the last 5 years, but we have not gotten to a point with our studies, with the blending, that we're comfortable incorporating that water, but that we're getting to that point now where in the fairly near future, in the next year or so, we're going to start to kind of blend some of that water with our surface water.
I think we drilled that well probably maybe 6 or 7 years ago. And we drilled it because we had known back then that at some point there's not going to be enough water in Lake Granger to take care of all the needs when we have a bad drought. So we looked at the groundwater in the area and we determined that it was a feasible and a cost-effective strategy to be able to use a little bit of groundwater to add to our surface water to increase our overall supply. But back when we drilled the well, we really didn't need it yet because there's still plenty of water in Lake Granger. And even today, there's still plenty of water in Lake Granger. What's driving us to do this phase 2 part of the project now, again, is the treatment capacity of the plant. We're about maxed out there, and we can implement this groundwater well more quickly and more cost effective than we can expanding the plant. So it's kind of the right time now to begin doing it. We really didn't need it. We went ahead and had the foresight to drill the well so that we didn't totally get behind the 8 ball and have to rush. We've got the well there and we've done some testing, and that's one of the other things that with groundwater you really don't know what's down there until you drill the well, until you exercise it and test it. And so we've got a good well, and it's just now is the time when we need to pull the trigger to implement the infrastructure to start using it.
Do we use groundwater anywhere else in the basin?
No, that's the only location. Yes, and we may end up drilling some more wells in the future. So out there, particularly there, not necessarily in other parts of the basin, we're not focused on that, but this project at East Williamson County contemplates several additional wells into the future as our water needs grow.
Okay, so you mentioned that this water need to be blended. Why? Why does the water need to be?
Partly because of water quality differences. This well is approximately 3,300 feet deep, and the water comes out very warm. It has a lot of total dissolved solids, and so those things make the water unpalatable. And so by diluting it with surface water, which has, is a little bit cleaner tasting, has better taste and odor qualities, it allows our customers to see maybe less of an impact to their water quality. And ideally, they won't notice at all. Right. So that's our ultimate goal, is to make it so we can supplement the surface water with little impact to the end user.
Yeah. You mentioned that the water coming out of the well is warm. What are we talking about?
It's about 112 degrees Fahrenheit.
Wow.
Give or take a few degrees, right? So it feels like a nice warm hot tub coming out. And so that's integral to the incorporation of groundwater, is kind of cooling things down. And when we go to talk a little bit more about what that infrastructure and what that project really looks like, cooling towers is probably the biggest component we're going to see, which is really evaporative towers that are designed to cool the water so we can disinfect it properly.
Oh, wow. Okay, so the water has to be a certain temperature before you can disinfect it.
Yeah, they like to get it down into the 80s.
Wow, okay.
And we're told those cooling towers are going to get it into the sweet spot, right?
Nice. Okay, so
One of the other things, Charlie, with the groundwater that we're looking at out there is a relatively new idea that's being more and more implemented in this country. It's been used elsewhere for quite a while, and it's being used here in Texas now in 2 or 3 locations and some other locations in Florida, and it's called aquifer storage and recovery, where we basically will take extra water from Lake Granger when it's not needed by our customers, run it through the treatment plant, clean it up, and then potentially inject it into the ground to store it underground for use later on. And we've done quite a bit of preliminary work out there and have determined that it looks like it's a feasible project for that location. The aquifer characteristics are conducive for allowing it to work. And so that's something else that I think we're going to test and explore some more as well. So in addition to using this well to blend the native groundwater that's in the ground underneath their feet out there right now, in the future, we may look at taking extra water out of Lake Granger, such as we've had this summer when we've had extra water in the lakes in the flood pool, treat that water and store it in the ground. And that's putting really and truly cleaner water into the ground than what exists naturally there. And if you think about it, in locations where it works, you create almost like a bubble of water underneath the ground. So the more water you add, you're expanding this underground bubble of water. And then, let's say we do that for 5 or 10 years, we're gradually and incrementally putting more and more water there. And then we have a really bad drought like 2011 and the lake gets low, we can pull more of that clean water out of the ground and use it. So that's something that it's still not 100% that we're going to do that and that it's going to work there. But we are looking at getting permits from TCEQ to test that and take the next step, because all the preliminary work and the desktop analysis that's been done indicate we've got a really good spot for that.
You mentioned a bubble. How exactly do you store water underground?
Most aquifers, like the Trinity Aquifer, are basically just layers of underground sand, and they have pore spaces in between the sand particles.
Okay.
And so those pore spaces hold a lot of water. When you're talking about maybe a sand layer that's 500 feet thick and, may run laterally for, miles or across multiple counties. And so those pore spaces hold water, and depending on the aquifer, water naturally moves through aquifers. All the water that's in the aquifers today actually came as rainwater. It fell on the ground somewhere, soaked into the ground, and gradually percolates through the ground. And so some of those aquifers, that water moves really fast. Most of them, it moves really slow. And for ASR to work, you want it to move really slow, because if you're putting water down your well, building this bubble, you may not need it for years. And so you want the bubble to still be here and not downstream underground somewhere 20 years from now. So again, that's kind of how it works with this situation in this aquifer. It's the Trinity Aquifer. It's very deep. It's over 3,000 feet deep, and the water moves very slowly. And so by injecting clean water, like I said, the best way I can describe it is just like if you are slowly blowing a balloon up, you're creating this balloon or bubble of water, if you will, in the aquifer. And around the edges of that bubble, there will be some mixing with the native groundwater. And so you'll have this zone where the water characteristics are kind of like the native and kind of like the clean. But the closer you get to the center of the bubble, it's going to be more like the clean water that you put down there.
Why would we treat the water before putting it below ground?
Most aquifers naturally treat the water so it falls as rainwater. All the water that's in the aquifers, fell as rainwater somewhere, and it was totally clean. And, say it hits the ground and it may get some contaminants from, animal poop or oil or whatever, but as it percolates through the ground's naturally filtering it. So most of the water that's in our aquifers is clean water, except for natural contaminants like salts and things. There's natural salt formations within the rocks and things that dissolve into it. But in terms of other contaminants, it's usually relatively clean, other than just natural things. When we're taking water out of the lake, our lake water, it's relatively clean. We go swim in it and we water ski on it and those kind of things, but it could still have some nasty stuff in there that's nastier than what's in the ground. And so with ASR, there are protections in place that require us to treat it so that we don't take nasty water out of a lake and put it into the ground and then contaminate water that was otherwise already pretty good.
Wow. Okay, that's really interesting. I love that. Okay, so we did re-rating at the plant. We're looking at blending. What's the next step for that?
Well, I think it's important to say that all of these things from a project standpoint are really developing simultaneously. So we're working on, there are 4 kind of separate components to the system expansion, and all of those are being worked simultaneously, but they are on different schedules.
Sure. And we're talking
about them one at a time, and maybe in order of priority, actually. So the next part of that is a treated water pipeline, an additional treated water pipeline. So once the water is treated at the plant, we have currently a 27-inch pipeline that runs from our plant facility to our customer take points in Circleville. So Circleville is on 95 outside of Taylor. And that's about 3.7 miles. It's about 3.7 miles. And so we have one pipeline currently. We're limited in capacity because it's only a 27-inch pipeline. And so this is going to allow us to put in a redundant pipeline, but also a much larger pipeline. So
what does a redundant pipeline mean?
Yeah, so that just means instead of having one, we're going to have 2 that are running simultaneously, but can also be somewhat interchangeable. So if one of them needs to be taken down for maintenance, we kind of have a backup
Okay, yeah.
to use, right? This new pipeline is going to be much larger diameter, and it's going to really meet our needs until we get to the max build-out of that facility. So it's going to meet our needs all the way into the future until we have to build a whole new facility. So when it comes to the easement acquisition process for the pipeline, we're working really closely with the potentially impacted landowners, and the BRA thinks it's really important to be a good neighbor, and we're trying to do that.
Yeah, I love that. Okay.
So the 27-inch pipeline, the current capacity is about 16 million gallons per day. This new pipeline is going to be greater than 54 million gallons per day. So that's going to meet our needs. I mean, our final build out for the entire system expansion is going to be around that 54, maybe a little bit more than 54 MGD. That's to be determined.
And I think Mandy mentioned earlier, we're working all 4 of these projects simultaneously, but this one, the pipeline is a priority because right now we've got that bottleneck. If we expanded the plant where we could treat, let's say we could treat 30 million gallons of water every day at the plant, we couldn't get it to the customers because the pipeline that it's got to flow through can only flow about 16. So the pipeline expansion is the next most important thing because, like I said, it doesn't do you any good to expand your plant where you can treat all this water if you don't have a pipeline to be capable of sending it to the customers. And so
Yeah.
that's why it's next on the list, if you will, beyond the blending and the re-rating that we've already talked about.
So they're currently working on the 60% design.
What's that mean?
The way our projects work at the BRA is typically we do a preliminary engineering phase. After that, we go into a design phase, and then we go into construction. So we're currently in the design phase, which is where our engineer really puts the final touches on their final design of this is what we're actually going to build. And we kind of have 3 major milestones within that design phase. We typically get a 30% design, 60% design, and either a 90 or 95% design, depending on the project. And then, of course, 100%, right? The 100% is all done and ready to go.
Yeah.
We're ready to build this thing. And so we're kind of right in the middle for this particular component, the pipeline component. So we're making really good progress there.
So with this expansion project, we have the re-rating, the blending, the new pipeline. You mentioned 4, so what's next? Or part of at the same time?
Yeah. So kind of the 4th component that we're looking at is an actual treatment plant expansion. So we're going to really expand our treatment capacity at the plant itself. And so really the infrastructure we're looking to add there is going to be new clarifiers, new filters, ground storage, so we can store a little bit more of the treated water and have that available for our customers.
With regard to the treatment process, there's several main phases of that. When the water comes from the lake, it goes into that terminal storage reservoir that we talked about earlier it's just like a small lake. And then there's some settling that occurs in that terminal storage reservoir. Some of the particles and sediment settle out there. But from there, the water goes into clarifiers, and those are, a big component of what we're going to need to enlarge and expand. And in those clarifiers, we add some chemicals and other things to help cause the big particles that are still in the water to coagulate and join together, and then they settle out to the bottom, and we get rid of that as sludge, so the water's a little clearer.
Okay.
Then we send it to filters, and these filters are big basins that are full of different types of sand layers, and the water flows through those, just like I was talking about with underground aquifers. The natural soil in the earth purifies water as it flows through, and so we have these sand filters there at the plant that filter out some more of the nasty stuff. And then once the water goes through the clarifiers to the sand filters, the last phase is disinfection, and we add something like chlorine or something like that to kill any microorganisms or whatever that's still in there.
Yeah.
And then from there it goes to what we call our clear well storage, where it's basically the water's treated and ready to go, and it's a big tank where we hold it before it gets pumped through that pipeline.
Okay.
And so this last phase of the expansion, we'll be looking at expanding all of those components, the clarifiers, the filtration capacity, and the storage in the clear well.
The plant expansion itself is going to happen in 2 phases. So right now we're kind of in the short-term expansion phase, which is going to boost our capacity to around 30 MGD treatment capacity, and that's scheduled to be completed around 2028. After that, we're going to start looking at timing for the long-term expansion, which is going to give us that final build out for that facility.
And that's going to be dictated by demand. So I mentioned earlier, currently we're maxing out at about 13. The short-term expansion that Mandy just mentioned is going to get us up to around 30 MGD when you look at the groundwater blending, the re-rate, and the new expansion all put together. It's going to be about 30. So that's more than double than we have right now. 2028 is now, 2.5, 3 years away. And so once we get there, we'll see what our demands really have been. If they're going faster than we think, then we may have to start the planning for that next expansion quickly. If things moderate and, we get to 2028 and we're only at 17 MGD and we've got 30, then, we'll wait until the time is right to start that last one, because it costs money to do all of this, and you don't want to do it too early because you burden the customers and the ratepayers with the cost before they need it. You don't want to do it too late because then you're late and people aren't getting the water. And so the next or final phase of the build out for the facility will kind of be dictated based on what we see in the growth in the population over the next 5 to 10 years.
Yeah. Well, a huge thank you, Brad, Mandy, for joining us today. I'm so glad you're able to come on and help kind of break this down for everybody.
Thanks for having me.
You're welcome.
So if while listening, you have a follow-up question or something more you'd like to learn about, please reach out. You can email us at information@brazos.org. We're happy to fill in any gaps. And if you have a topic you'd like to learn more about within the Brazos River Basin, whether it's water supply, conservation, or reservoirs, water treatment, anything, please feel free. Information@brazos.org. And with that, we're out. Join us next time on Unpacking the Brazos River.